There are two main types of IC engines, spark ignition engines and compression ignition or diesel engine. Both these engines are further classified as two-stroke and four-stroke engine. Internal combustion engines, more popularly known as IC engines, are the ones in which the combustion of fuel takes place inside the engine block itself. After combustion of fuel, much heat energy is generated. This is converted into mechanical energy. There are two types of IC engines, rotary and reciprocating engines. In rotary engines, a rotor rotates inside the engine to produce power. In the case of the reciprocating engines, a piston reciprocates within a cylinder. The reciprocating motion of the piston is converted into the rotary motion of the vehicle's wheels. In automobiles, reciprocating engines are used. They are the most widely used type of engine. Reciprocating engines are classified into two types, spark ignition engines and compression ignition engines. Since reciprocating engines are the most widely used engines, they have become synonymous with the name IC engines. It is this reason that even the IC engines are broadly classified into two types, SI engines and C engines. In SI engines, the burning of fuel occurs by a spark generated by the spark plug located in the cylinder head of the engine. Due to this fact, they are called spark ignition engines. In these engines, the fuel used is petrol or gasoline, hence SI engines are also known as petrol or gasoline engines. In the case of C engines, burning of the fuel occurs because of the high pressure exerted on the fuel. The fuel is compressed to high pressures and it starts burning, hence these engines are called compression ignition engines. In C engines, the fuel used is diesel, hence they are also called diesel engines. The SI and C engines are either two-stroke or four-stroke engines. In the case of the two-stroke engine, for every two strokes of the piston inside the cylinder, the fuel is burnt. This means for every single rotation of the wheel, the fuel is burnt. In the case of four-stroke engines, the fuel is burnt for every four strokes of the piston inside the cylinder. That means each time the fuel is burnt, there is two rotations of the wheels of the vehicle. The stroke is the distance traveled by the piston inside the cylinder. It is usually equal to the length of the cylinder. Since the four-stroke engines produce two rotations while two-stroke engine produces single rotation each time the fuel is burnt, the efficiency of four-stroke engines is greater than in two-stroke engines. Ideally, the efficiency of the four-stroke engine should be double of the two-stroke engine, but in actuality, it is never so.